My name is Dr. Mike Murphy. I'm an assistant professor of computer science and information systems at Coastal Carolina University. In this lecture, I'm going to discuss file systems. I'll be providing an overview of the purpose of file systems, discussing metadata that they store, explaining how we create a file system through a process known as formatting, talk about some issues with file systems, including fragmentation and journaling, briefly discuss some internal layouts used by different file systems, and finally talk about mounting and unmounting file systems to make them available to users. A file system is responsible for laying out data on a persistent storage device and ensuring that data can be retrieved reliably. The file system is an abstraction of disk space. It provides routines for querying, opening, and closing files, and providing human-readable names for files and some kind of organizational structure for files, typically through directories or folders. Without a file system, we would have to access disk by physical location or by address, and each program would have to reserve certain address limits for its exclusive use. File systems, in addition to performing this abstraction, also arbitrate disk space among different programs and different users of a computer system. File permissions allow users to have a certain degree of privacy, while file quotas ensure that one user does not monopolize the entire system by utilizing all the disk space. File systems are also responsible for storing metadata or information about each file. This includes a file name, file size, who owns the file, what group that owner belongs to, what permissions exist for each different category of users on the system to access that file, as well as to provide certain timestamps. On Unix, we have the inode creation time, the file modification time, and optionally the last file access time. Metadata records also include internal information that is important for the file system itself, such as pointers to the actual data on disk, and a reference count for how many different names refer to the same file, a system called hard links. We create a file system by taking an empty partition, or a partition that we're ready to reuse, and formatting it. Formatting, quite simply, is the process of making a new file system on an existing partition. Formatting typically destroys the structure of any file system that was previously installed on the partition. Thus, when you format a partition, you lose the access to its contents, at least through standard tools. However, unless that free space, unless that partition is securely erased, the contents that were formerly on the partition can still be recovered using forensic tools. The only safe way to switch between file systems on a single partition is to back the data that's on that partition up to another disk, format the partition using whatever the new file system would be, and then restoring the data from the backup. There is no safe way to change a file system type in place without losing data. The file systems do suffer from a few issues. Over time, sections of a file in a file system can become non-contiguous. In other words, a file gets split over different parts of the disk. And in the process, that also splits up the free space, so that when new files need to be allocated, they have to be split up to take advantage of smaller blocks of free space. This is a situation called fragmentation. It's worse in some file systems than others. Fragmented file systems were a big problem with mechanical hard drives, simply because a fragmented file requires a seek to move from the location of the first fragment to the location of the next fragment, and possibly further seeks if there are more fragments. Not so much a problem on solid-state drives, however, since there's no seek time. And file systems can get around this problem either with offline defragmentation tools that the system administrator can run manually, or they can use fragmentation avoidance strategies or automatic on-the-fly defragmentation. Another issue that can occur with file systems is that a single high-level file system operation typically requires several low-level steps in order to complete. If the computer should crash or power be lost in the middle of those steps being performed, the file system could be left in an inconsistent state. A solution to this problem is called journaling, and the way this works is by recording all the steps that are to be taken in something called a journal, a special part of disk space reserved for this particular information. Records all the steps that are going to be taken prior to taking the steps. Thus, if the system should crash in the middle of a file system high-level operation, all that needs to occur is the journal simply needs to be replayed next time the file system is mounted, and the steps can be carried out again and leave the file system in a consistent state. Internally, file systems may use one of several different approaches for storing data on the disk. A simple layout is called the file allocation table, which simply has a single table in each partition to store metadata and the addresses of data segments for each file. File allocation table type storage methods are limited only in terms of how big the file allocation table can be, and these limitations specify, among other things, the maximum size a file can be and how many files can be on the system. Another approach is to use something called inodes, which are data structures on Unix systems that contain the metadata for a file, including pointers to the actual data. Inodes do not store the file names, however. These are stored in a separate structure called a directory that maps file names to inodes. The maximum number of files that a single file system can hold is limited by the number of inodes created when the file system is formatted. This can be a particular problem for file systems that wind up storing a really large number of very small files. There could be plenty of space left on the file system, on the partition. However, if the number of inodes is exhausted, then no more files will be able to be created. Another approach to storing files and laying out data on the file system is through the use of extents. Extents support larger maximum file sizes because they're designed to allow files to be composed of several non-contiguous blocks of space, much like fragmenting that could occur with a file system that doesn't use extents. Extent information is stored with the metadata in the file inode or some other type of data structure for file systems that support extents. Now, regardless of how the file system lays out its data internally, we need to make the file system available to users and programs on the computer. To do this, we perform a process called mounting. Mounting is the act of making a file system available to the users of the system. The opposite process is called unmounting, which is disconnecting a previously mounted file system. Unix systems mount file systems at mount points, which are simply directories somewhere within the overall directory structure of the system. So if I plug in a flash drive on a Linux machine, for example, that flash drive may be mounted at /media/my_drive. I can mount a large number of different file systems this way at the same time, and I can make all of the different file systems appear to be part of one directory structure. On the other hand, Windows systems use drive letters, where the letter C is reserved for the system partition, the one on which Windows is installed, and A and B are reserved for floppy drives. Windows supports a maximum of 26 file systems to be mounted at once, simply because that's the number of letters that are available to assign to drives or to assign to partitions. So in summary, file systems organize data, store metadata, provide an abstraction of the underlying storage medium, and arbitrate access to the storage space. We create file systems through a process known as formatting. We can make file systems more robust against data loss during a power failure through the use of journaling. Internally, file systems use various different mechanisms for laying the data out on disk, but no matter how they work internally, we can make them available to a running system by mounting them.